Hello, today we are going to solve one problem from Code Forces and its name is Arpa's hard exam and Mehrdad's name cheat. It will use the concept of modular arithmetic and the exponent number theory concept it will be using. So I will be explaining the concept together with the code. So let's come to the question. There is an island. This as simple as that. You will be given n and you have to calculate the last digit of 1378 to the power n. Okay, so how do we calculate the last digit of any number? We simply take the modulo with 10 of that number, that gives the last digit of that number. So for calculating that, we have to calculate the 1378 to the power n. But see the restrictions here. N is to the 10 to the power of 9, which means it can go to a very large number. For that, we have to control the overflowing of the condition that int can store only up to 10 to the power of 9. So for that we will be using some techniques so that we can, instead of doing 1378 to the power n, we can do some smaller number to the power n, and what number it should be. For that we have to use the congruency relation of the modulo arithmetic. So let's come to that concept. So the concept says that we will be discussing these three concepts. Let's come to the concept. First concept is that the congruency relation. This is the congruency relation. A and B are congruent to each other if with respect to modulo m, if A modulo m is equal to B modulo m, then we say that A is congruent to B with respect to m. So one property says that if A is congruent to B with respect to modulo m, then A raised to the power of k is also congruent to B raised to the power k with respect to m. So this is the first property. The second property, second thing that we will be using is the binary exponential. How we calculate the binary exponential in log n complexity. Suppose we have to calculate a raised to the power of n, then you can simply use the for loop n times and multiply a each time. So for that will be complexity of order of n, but we need order of log n, because 10 to the power of 9, n is 10 raised to the power of 9, which means it will give TLE if it is order of n. So we have to log n complexity is required. So for that we use binary exponential method, and here is the code. Let's see the code. This is the code for binary exponential. We will be, if n modulo 2 is not equal to 0, means if it is odd, then we will be just result will be multiplied with a and we will just increment n. But if it is even, then we will be doing exponent the base in which we have to calculate. Here base is a and exponent is n, so we will just square the base, means, and the exponent will be divided by 2. What I mean to say is that suppose I want to calculate 2 raised to the power of 4. Okay, this is the test case. Suppose, so if it is odd, this is the result, what we call variable, this is n, and what are the variables else? Result variable, n variable, and a variable. Okay, and a variable. Suppose we here a is equal to 2, n is equal to 4, and currently result equal to 1. Now since n is not equal to 0, so it will come and n is even. So what it will do, if n is even, then it will just square the base a, and it will be divided by 2. Now again check, n is not equal to 0, so it will just square the base, and n is divided by 2, 1. Now n is odd, so what it will do, result equal to result into what? A, and here a is what? 8. Resulting a is equal to here a into a, na? So 2 into 2 into 2. Now since a is equal to n is odd, so what it will do, result equal to result into a, that is this one. So this is equal to 16. So result equal to 16. So this is the method of calculating the exponent in log n time. Now the third property is, if you want to calculate a into b modulo n, suppose a is equal to, third property it is, suppose a is equal to 3, b is equal to 4, and n is equal to 2, suppose, and you suppose to want a into b modulo n, you want to find it. So 3 into 4 is 12, modulo 2 is 2. Instead of doing this, you can also do this. A modulo n into b modulo n, whole modulo n. Let's do this. 3 modulo 2, what it is? 3 modulo 2 is 1 into b modulo 4 modulo 2 is 0, modulo is 0 now. B modulo n is 0, 3 modulo 2 is 1. One into 0 modulo 2, and 0 modulo 2 is 0. So you can calculate in either way the modulo. For the purpose for which it is used is when a and b are very large, it can exceed to a very large number, it can cross 10 raised to the power of n. So for overflowing purpose, it is used in this way. So let's come to the code. Simply we have taken the input n, and we have called the power function having the base 8 and n raised to the power of n modulo 10. And this is the power function. If n, while n is not equal to 0, we will go on. If n odd, even, here if n is odd, then we are just result equal to result into a, and we are decrementing n by 1. Otherwise, if it is even, then we are multiplying the base. We are multiplying the base with a is equal to a into a, and we are decrementing the n by n divided equal to 2. So this is the method for finding the exponent in order of log n time. So hope you have got the concept. Thank you very much.